Hello everyone. The topic today which we will be dealing is two pointers algorithm. Before starting with the algorithm, first what we should understand is on what type of data this type of algorithm will run and what should be the output regarding this. Actually, what happens is whenever you have been given a set of elements like an array, it should be sorted. It should be a sorted array or a sorted linked list. And to find, it should be a set of elements based upon the constraints. Now, the constraints means the target. Based on these algorithms, what you can do is we can find out the pair of a target sum. You can go with triplets, or we can go with even finding out the subarrays also. So as you can see, I'm having a small example with me where the input data is nothing but a sorted array, a target sum has been given, and an output has been given. So if you see the output exactly depicts that it is the index number of the elements. Like 1 represents the element that is 2, whereas this 3 index number represents the element 4. Means what exactly is happening is, if I go with the explanation, it means that the element present at index 1, that is 2, and the element that is present at index 3, that is 4, when sum is equal to the target sum that is given to you. Means this is your basic question. And if at all, the target sum in place of 6, it would have been 7. And for an example, if in the place of target sum, in place of 6, if the target sum would have been, if you say it's 9, is 9, and you see the question over here, what is happening, where I'm getting 9, I'm getting, if I add 3 and 6, I'm getting that it is 9. Means the output at that time would have been the index number of 3, that is 2, and the index number of 6, that is 4. So this is what is the question. Whatever the target has been given to you, you have to search that two elements or the pair which when added gives you this exact result, and the output will be the indices where these elements are being placed. Again, we can see if a target for an example is been given as 11. So what is happening? You go on pairing the elements and finding the sum, and what we can see is we don't find any of the element over here whose target is equal to 11. At that time, what is happening? The output is given as -1, -1. Means if the target does not exist, what is happening? The output is your -1 and -1. So this is what is your basic question. So for now, first let us see how we will be doing with brute force, and then we'll apply our two pointers algorithm in that. Suppose I go with my brute force approach. So in brute force approach, what is happening? The same question we are taking. You're having the elements, and what do? We'll be placing one pointer over here and the other pointer in the next element. And what you are trying to do is, we'll be taking the very first element and then all the remaining elements that are present, and it will be moved or pointed by this particular second pointer. What we will be doing is, we'll be adding these elements. First pointer points to the first element, so that element has been taken, and then whatever the element this second pointer is pointing, you take that element, you sum up, and then what you do is you compare with the target sum. If at comparison you get the pair, what we do? We return the indices. So these indices are being returned. If you are not getting this, what is happening? The second pointer is again incremented. You go for the next element, you add with the very first element that is pointed by the first pointer, and then you again compare with the target sum. So nothing but what exactly we are doing is, we are taking the first element and trying to find out a pair from all the remaining elements so that we can get a target sum. Once first element is being paired with all the remaining elements and you don't find your desired output, what is happening? Now this first pointer is being traversed, it is being incremented, and then now we start with our second element. Whatever your second element will be, you start with this. The second element, the pointer will be here, and then the second pointer will be placed next to it. And whatever the remaining element is there, you will be adding there. So what will happen here? 2 will be added with 3, you get 5, so it is not equal to the target. Then the second pointer is again incremented, then again it is added, and here what is happening, you get your target sum. Once you get your target sum, the indices of these two elements are being sent as a return data. So this is the basic question. So when I do this question with this type of a solution, what is happening? You are taking two pointers but placed simultaneously, and every time for the first element, all the remaining elements are being checked. Then again for the next element, again remaining elements are being checked. Nothing but when we go with this approach, the time complexity over here becomes bigger of n square. We can do this question with this approach. But what we are trying to do is, we are trying to find out an efficient or a better approach. So the better approach over here is nothing but the two pointers algorithm, which I'll be dealing now. So coming up to the two pointers algorithm, what happens over here is, same data we'll be taking. You're having a sorted data, and you're having the target sum. So what we do is, we take two pointer, we place one pointer at the start of the array, and we take another pointer and we place this pointer at the end of this array. Means I take a left pointer and I keep it at the start of the array, is nothing but at index number 0. Whereas I take one more pointer, that is the right pointer, and I place the right pointer at the end of the array. So how do I get the end of the array? Is nothing but the array size over here is 5, and the index number, since it index started from 0, it is -1. So the right pointer I'll be placing at array size -1, nothing but I get the right pointer's index number as 4. So this is the placement where I go for the placing of these two pointers. Now how the movement should be done? What we do is, the first process, you place the pointer and you find out the current sum. Now what is this current sum? Current sum is nothing but addition of the element that has been pointed by the left pointer and the right pointer. Means this is your array. So array is left and your array is right. This has been taken. So what is happening when I write this? At arrays left is nothing but your ARR of 0 plus your at the fourth position. So what is this element over here? The element over here is 1, and what is at fourth position? 6. So nothing but my current sum becomes 7. This is the first thing that we do. Secondly, what we are doing is, you try to compare. Compare what? You compare the current sum and the target sum. Means the 7 is being compared with 6. Right. Now, how it is the comparison is, if my current sum is equal to my target sum, what will happen? I'll be sending back these two indices. Indexes are being sent, right? And if they are not equal, since in this example we are finding they are not equal, what we find here is, our current sum is greater than our target sum. This is nothing but the cases which you are having. You will be finding two cases. First case will be where my current sum is greater than target, and the second case will be where my current sum is less than the target. So in this scenario, how the movement of the pointer takes place? When your current sum is greater than the target sum, what does this mean? It means that since our data is in sorted manner, means wherever the right pointer is pointing, this will be the largest one. Here, what we are getting is, we are getting a larger sum comparative to our target. So we have to decrease this value. The sum should be less compared to the target. So what we do is, we move our right pointer, nothing but we go for decrementation of our right pointer. Since you decrement the right pointer, what is happening now? My right will be pointing in this particular position. Right. So my right has been pointing here. Now what I do, again the same scenario takes place. Again you go, you find out again left is at 0, now right is at the third index. The value of this element is 1, whereas the element at the third location is 4. Now what I get is, I get 5 as my current sum, which shows you the second case, that is current sum is less than the target. What is happening over here? 5 is less than the target sum, 6. It means that I have to increase this value. So I have to increase any of these elements over here so that I get this current sum higher, so that it can be comparative or compared to this particular target sum. At this scenario, what is happening is we move our left pointer. Nothing but what you do is you increment the left pointer. So when the left pointer moves over here, again you go for the calculations. The same repetitive steps have been taken place. Now what is happening? Right. So what is happening now? My left pointer is placed at 1, whereas the right is placed in the same position. The value at the left is nothing but 2, and at 3 it is nothing but 4. Here what is happening? I am getting a current sum which is equal to the target sum, and nothing but you have found your desired output. So what you do? You return the index number of this value, nothing but this 1 is being returned, and similarly you return the index number of this value, nothing but your 3 is returned, and my output is 1 and 3. So this is the basic concept of your two pointers approach. Now, up to what limit this left pointer should move, or up to what limit this right pointer should move? What will happen is, this movement of this pointer will be nothing but our condition, up to what our iterations should go on, and these particular steps like finding out, calculating the current sum, comparing with the target sum, and then if not equal, going for the cases, these things will be taken place. So what will happen is, until and unless my left is less than right, we will be doing this process and finding out if our current sum is equal to the target sum, right? So what is happening? If you can see, if my left is also moving and right is also moving, and it is moving up to this condition, like left should be always less than right, it means that the whole array that is being given to you will be traversed only once. And when we say it is traversed only once, nothing but the time complexity will be bigger of n. So I hope you have understood the approach, what we are doing over here. We'll be coding it properly so that you can understand the whole process and see the output also. Let's see this question of lead code, that is 2 sum. What is given over here is, first we'll just go through the question. What is it given is that you will be given an array of integers, that is nums, like you can see over this example. You have been given a target, and what you have to return? We have to return the indices of the two numbers such that when they are added up, they are equal to the target. This is your question over here, right? So let's see the first example, and then we'll come to the second example also. Because why I'm saying first example and second example is, if you can see, the first example is a sorted array, whereas the second example is an unsorted array. And as we said, two pointers approach will be only working on sorted array. So first we'll see how it works on the sorted array, and then what are the changes to be needed so that it can work on unsorted array also. So what you are having? What you are having? You have been given a sorted array, right? So nothing but this is a question of 2 sum, where we'll be giving pass on. You'll be passed two parameters over here. One is your vector as nums, and another one is your target. Since we have a return type over here, like you have to return the indices, so we take a vector so that it can take. Now, what is happening in this question is, we have to return a pair means two values are being returned. So for that condition, what we are doing is we are taking again a vector so that it can store this value. So let it be a result, and what I am doing is I am taking this. What does this mean now? It means this 2 indicates that the size of this vector is 2 and it has been initialized by -1. Now why I have taken this? This I have taken because, right, it's okay. This I have taken because what it was given in the question is, if at all it doesn't exist, what we have to return? We have to return -1 and -1. So when I take this vector, it means that there is a vector the size is 2, means it is having two indexes 0 and 1, and initially the value that is stored in this is -1 and -1. This only will be returned when we are not getting a desired output, right? Now what we have done, we have taken 2 pointers, so I am taking the same 2 pointers. Left we are placing at the 0th index and the right you are placing at the end of the array. Right. Now what was the condition for we have taken? That our left should be always less than right. The very first thing what we will be doing over here is calculating the current sum. So what is the current sum? Our current sum will be nothing but equal to the left index data plus our right index data. Once your current sum has been calculated, what we are doing? We will be comparing it. Comparing it with what? We will be comparing with the target. So if my current sum is equal to the target, what are the things I have to do? I have to return the indexes. So now first thing what happens is I have to take and I have to place the indexes in this particular place. Then I have to return this vector. So what I do, as we have taken that, in the 0th index, I will be storing the left index value, and in the one index, I will be storing the right index value. So nothing but your result 0th index will be holding the left value and your result 1 index will be holding the right value. And once this has been given, simply we will be returning the result. So this is the condition when the current sum is equal to our target sum. If at all it is not equal, then what we have? We have two cases. So what are our two cases? I'll be continuing the code over here. If my current sum is less than the target, so else if my current sum is less than the target, so what we do? We increment our left index. Else what we'll be doing? We'll be decrementing our right index. So this is the scenario that is taking place, and this iteration will be taking place until and unless my left pointer is my left value is less than my right value. So if at all within this given the iteration that is running over here, if I don't get my desired answer, what it will be doing? It will be simply checking that if the left is more than the right, what is happening? You come out of the loop and it will be returning the result. So your just result is been returned back. So this is the basic, or what you can say, this is the function behind this two pointers approach. Now we'll just see how to for an example, we'll just take this example and see one iteration, and we'll see the output if we what we have thought in this whole process, we are getting the output or not. So what is happening? Left we have pointed out at 0th index, right you have kept over here. You calculate the current sum. So our current sum is equal to nothing but 2 plus 15, that is 17. Now compare 17 is equal to 6. What is the target? Sorry, 9. If 17 is equal to 9, no, it's not equal to 9. So you just come out and you check if current sum is less than 9. So no, it's not less than 9. So what we do, we go for the else condition and you decrement the right. Means now the right moves to this particular position. Right. Now, since it's in a loop, what is happening? My left is at 0 and my right it as 2. So, 0 is less than 2. You enter. You again enter the loop. You again try to find out the current sum. What is the current sum? 2 plus 11 gives you 13. You compare again. If 13 is equal to 9, so it's not equal to 9. You come out of this if condition, you see over here, if 13 is less than 9, so it's not less than 9, you come to else, and again what is happening, my right is decremented again and right comes over here, right. Again the iteration takes place since the left it as 0 and right it as 1, so 0 is less than 1. So we find 0 is less than 1, true. Again you try to check the current sum. What is the current sum? Left is pointing at 2 and your right is pointing at 7, nothing but a current sum is 9. So we go for comparison. That 9 is equal to 9 and yes, you get this target. So when this condition goes true, now we come over here. What is happening? At the result of index 0, what has been given? The left value is given. And what is the left value? The left value is nothing but 0. And to the index number 1, the value of right has been given. And what is the value of right? 1. And what do you return? You return this result. So here what is happening? This has overwritten by 0 and this is nothing but your 1. And what you are returning is, you are returning this particular result and that is nothing but your output. So this is the way how you solve the question. But as you can see, we have taken a sorted data and it is working in this. But if at all, again, we go with the second example. You go with the second example. Our second example is nothing but an unsorted data, 3, 2 and 4, right? And the target is 6. Just think putting up the same 2 pointers approach in this. What is happening? I'm putting the left pointer over here, right pointer over here, and I'm finding the current sum. So what do we get? We get 3 plus 4, nothing but 7, and you compare it with 6. So 7 is greater than 6. And what happens whenever you find the current sum greater than 6? We move our right pointer. So I move my right pointer. And then what happens? I go for calculation. My right pointer is pointing over here. So 3 plus 2, nothing but 5. Now you get that the 5 is less than 6. Means what I should move? I should move my left pointer. So my left also comes over here. And when my left and right both are at the same place, because what is our condition? Our condition is left should be less than right. So when the left and right both points in the same location, what is happening? The condition goes wrong and you come out of your program. But if you see this scenario, what is it? The data is 3, 2 and 4. Here if I add 2 and 4, I'll be getting 6. Means what we are thinking with the 2-pointer concept, it is not working on unsorted data. But the example is given in this. So what we should do over here is, first you should sort the data and then you should use the same concept over here. Coming with that, as I said, we should sort the data. So let's sort and do this. Since this is the data given, as I said, let's sort. So after sorting, what it becomes? 2, 3 and 4. If you see, the index number of the data has changed. And when I go for the current sum, what I find is, this is the actual elements when added will be giving me the target. Means 2 plus 4 will be giving me the desired target, that is 6. And what is the index of 2? The index of 2 is 0, whereas the index of 4 is 2. But if you see the output, it is 1 and 2, means it is showing the indexes of the given data only. But since we have sorted, we are getting the result different, means we can't go with this particular logic. What we should do in this particular question is, first we should store the indexes of these elements beforehand, and then we should go for the sorting. So when you do the sorting and you use the two pointers approach and you get your answer, while returning, what you return is not the indexes of the element after sorting, but what you have stored already, previous only when the question was given. So this way what is happening is you are actually holding the index number or the actual indexes of the element, and when you return back your output or the answer, it won't. What will happen over here is, since you are storing the indexes of the element beforehand only and then you are going for sorting and using the approach, after that also what is happening, there won't be any disturbance in the output and you will be getting the exact result based upon what the input was given and not what you have done to the element while processing the data. So now we will be working on this unsorted array. Since an unsorted array has been given to you, we will take the same example. And your target has been given. Target is 6. Right. So same function name. And your target. And you will be having a return type. So we are taking a vector for that. So as I said, we will be storing the elements and its index number before sorting the data. So for that what I am doing is, I am taking a pair. Take a pair. And what you will be doing, you will be pushing all the elements that has been given in your example, and along with the elements, that index number will be also pushed inside this particular vector. Simple pushback function you have to use over here for the whole array that has been given. So pushback function has been used, and what are the things we are putting inside this array is the element and its index number. So elements will be given by your nums I and its index number is I. Means what is happening? You have been having an vector array which will be having two things in it. First the element and its index number. So when I is at 0, nums I and the index number 0, means index number is 0, and what is the first value of this element? That is nothing but 3. Similarly, the second element will be stored with the index number 1 and the third element is stored with the index number 2. So this is the way how your data is being stored beforehand only. Beforehand in the sense before sorting the data. Here how do we now retrieve it? We retrieve the data as terming this as the first and this as the second. Means whenever I have to work on this particular element, I will be calling it as dot first, and whenever I have to work on this second one, I will be dealing with dot second. So now what happens? Once you have pushed back the data or stored the data inside this array, simply you go for sorting. So you sort the array. And we have sorted the data. Means now what happens? This data has become as your 2, 3 and 4. To this, now you go for your two pointers approach. What's our two pointers approach? A two pointers approach is nothing but taking a left pointer and taking a right pointer. Similarly, writing the condition, and after that finding the sum. So your current sum, what is a current sum? Current sum is nothing but ARR's left but the first value, means its element and not the index. Similarly, your right, and to this also the first element. So this is how you will be finding the current sum. Next, you go for the comparison. The same way what we have done, it is the same thing which you have seen in the previous example. So your current sum is being compared with the target. If the current sum is equal to the target, what we are doing? We are returning. So now what you return? You return the index number. So we return the index number over here. What are we doing? We are returning the index number. Means what you do? You return ARR left. What value we have to return? We have to return the index and not the element. So where the left is pointing, its second value. Similarly, where the right is pointing, its second value. This is what you return if at all your condition is true, right? Else, if the same thing, your current sum is less than target, you go for left increment, else you go for right decrement. This is the way you will be doing this question, and then you return. If at all you are not finding the target, what you do is you return two values, that is -1 and -1 simply. So this is nothing but the question that to be solved with two pointers approach, and this is actually a very efficient approach because it is giving you the complexity as big of n. Try to solve this question using this method. If at all you are finding any issues or any complications while doing it, you can let me know. Thank you.